Welcome! It's been some time since the last video. An update. The hydraulic ram on the keel failed and it's been repaired. It's taken more than 6 months and it's now with the engineer. They've had some challenges machining the outer stainless steel tube. Hopefully it'll be working soon and I can conclude that video. It has a lot of content. Coming up, I refurbish the wind self-steering unit and build a wheel adapter. I find that this is the monitor self-steerer. It's been a little bit underwhelming so far. It hasn't really worked how it should. The other day I was out and I could pull the control line against the paddle, and that's something you shouldn't be able to do with a servo pendulum self-steerer. They usually rip your arm off. So there's something up with it. So I took the paddle off. This is it here, and there's a bit of tube that ran in between and it was bent. So obviously this line here, which is sort of like a bit of a counter, you draw a line up the middle there, gives it a bit of power, was gone because it was bent backwards. So that power had gone, so I'm going to replace it. Got another piece of tube here, the right size, and cut it to length, and it should be straight then, and hopefully that will give it a bit more oomph. The wind self-steerer is an important piece of kit when sailing short-handed. I need to get this wind self-steering unit working well. It will be doing the majority of the steering under sail, and I'll only be using the electric autopilot when motoring close to the shore or it's not handling the conditions well. I need to build a wheel adapter because what I was doing just didn't work well and it was difficult to adjust. I estimated what I think would be the correct diameter. It's quite a bit larger than the one sold by the manufacturer. The reason is that from lock to lock, the wheel only turns a bit over one turn. So when steering haphazard, you only need small movements of the wheel. Also, the rudder bearing is tight, and that makes the steering a bit stiff. So I've been putting grease and lubricants on the rudder bearing, and it helps. So to construct the wheel adapter, I have some leftover 8mm perspex from the windows in the Dodger, and I cut 3 circular discs. Using a router to put a half round on the 2 outside discs. These aluminium parts are for the backing plate and will be attached to the wheel. Cutting the 3mm alloy with a jigsaw. The idea is that the perspex disc will hold the control lines and rotate on the aluminium backing plate. And these holes being drilled are for the center access. One of my neighbours was doing some welding on board and kindly welded up the backing plate. This is the tricky part because I don't have a drill press. I'm using a block of wood to try to keep the drill square. There's lots of holes and I don't want them drilled off at different angles. These holes will lock the aluminium backing plate onto this wheel. A hole every couple of inches for weather helm adjustment, and will lock into position with an 8mm pin. Better I demonstrate that later. There's always some risk when building things for the first time. Will it work? Have I designed it correctly? The next part is the air vane. I cut these from plywood in Australia before leaving, and they do work, but there is room for improvement. I ordered a piece of high density 1/2 inch foam and I shaped it using the router to round the edges. Epoxy resin with fiberglass cloth is going on both sides. It's commonly known as foam sandwich, and it's very strong and super lightweight. This is another experiment, but I'm pretty sure it will work better. I've put the layer of fiberglass and epoxy on the other side now, and it went a lot better than the first side because I managed to get it around the edges. And well, we're just going to have to wait and see until it sets to see how rigid it is, because the foam sandwich construction is only good as the 2 outside layers. So we'll see about it soon. Mounting the backing plate to the wheel and fitting the control wheel and control lines. And now it's time to go out and try it out. Heading out, the wind was only 7 to 8 knots. The keel is all the way up. To operate, steer the boat on course, adjust the air vane into the wind so it's upright, engage the pin into the backing plate, easy done. The log wasn't spinning, so I had to clear it to get the true wind angle and speed on the wind instruments. The true wind speed, that's the one down there, TWS, and then the one above it there is AWS, is apparent wind. I decided to fly the drone off the boat for the first time. You really need two hands on the controller to fly, so that makes landing difficult. I will need to improve my technique at landing. In light air sailing, it was doing well, and on the way back the wind picked up to 10 to 11 knots. Sailing with the keel all the way up haphazard was well powered, and the self-steering was working great. The wheel adapter works. I will be doing more trials at different wind angles, and the true test will be sailing downwind. I hope you enjoyed the video, and until next time, happy sailing.